Okay, so this is the first of a few matrix applications that we can do, finding the area of a triangle. If we look at these, what we're given here, 0.1, -1 as the first point here. Plot these points. There's 1, -1, and then if we go 2, 1, 2, 3, and then if we take 5, 3, 4, 5, -3, so we have something like this triangle here. If we think about it, we could find the area of this triangle. We could use the distance formula to find the measure of one of the sides. Now, presuming that this angle is not a right angle, we're going to have to work to figure out what the height is. And just briefly talking about that, I would need to know this line here. I'm highlighting that line. We would need to know its slope, and then we would need to find the equation of the line that goes through this point up here. So we need the equation of the line that goes through that point and is perpendicular to this line, and then we would be able to find that point of intersection, and we'd be able to find this distance. So that would be a pretty involved process. I think you can see that. So look at how easy matrices makes this. I'm going to take and set up a 3x3 matrix. And just give myself a little space here. And this 3x3 matrix is going to have the 3 points. So 1, -1, 2, 3, and 5, -3. So I said a 3x3 though. So this third column is going to be ones. It's always ones when we're doing this application. Now now you can see that I've set this up. It's actually not, well, it is the determinant of a matrix that we are going to find. So we're going to find the determinant of this matrix, and I'll go ahead and set that up really quickly here. So I've set it up using the additional 2 columns, and we're going to use the diagonal method. So you'll recall, I'm sure, that we're going to multiply across this diagonal, and we'll get 15, and we'll multiply across this diagonal and get -3, across this diagonal, -2. Okay, so I'll continue that process and find the determinant. So there's the determinant, and I'm not so interested in doing this determinant by hand necessarily at this point. We could use a graphing utility to find that determinant, but we've got the determinant as -18. Okay. Now remember, we're looking for the area of this triangle. Well, the area of the triangle is going to be the determinant that I set up, and then I'm going to multiply it by plus or minus 1/2. Kind of like finding the area of a triangle, right? We say the area of a triangle is 1/2 base times height. So I'm adding this 1/2 here, or multiplying by this 1/2, and it's going to be plus or minus. Well, in this case, I've got a -18. So to get my area, hopefully it's obvious that I'm going to multiply by a -1/2, so that it comes out as a positive area. Therefore, the area of the triangle is going to be -1/2 times -18, and that is going to give me 9. So that's a pretty neat trick, particularly when you think about the diagram that I drew over to the left here and how involved it would be to find the area using the methods that I was describing versus using this method here where I was multiplying by plus or minus 1/2 of the determinant. Okay, so I think we have time to look at another application. And here's this other application is going to be solving a system. So we're going to solve system with Cramer's rule is what this is. And here is our old friend, the system of equations, right? We have so many ways of solving a system of equations. And again, it's not necessarily the solving of the system that's important, but seeing how we can apply different tools and techniques that might be useful later on. So for this one, to solve this Cramer's rule, matrix D, and D is going to be the determinant of the coefficient matrix. So I take the coefficients only, and all right, so there we have that determinant, negative 28. Now I'm going to have a determinant sub x, and that's going to be the square matrix again, and it's not, I'm going to write this down like that matrix D that I just had, but I'm going to replace part of it, and I'm going to replace the part that I want to solve for. So in this case, because I want to solve for x, so that hence D sub x means I want to solve for x, right? So since I want to solve for x, I'm going to replace the x's with the solution side, so 4, 1. So this 4, 1 is coming from up here. So this 4, 1 is, I'm placing that here. Okay? And there I have another determinant to solve. And then I would also have, in order to solve the system, remember we're trying to solve this system, in order to solve the system, I'm going to want a D sub y. So this is, I'm going to be solving for x and solving for y. So I'm going to get this D sub y, and that is going to be, again, I take the coefficient matrix, and I'm going to replace it, right, just like I did for the x. I'm going to replace this column here with the 4, 1. 4, 1. I'm replacing the y column, in essence, is what I'm doing. So let's just quickly calculate these determinants. I've got negative, not 24, negative 23, right? And for D sub y, I've got negative 2 minus, or I've got 2 minus 24, right? So that would be negative 22. Okay? Now the solution to the system is going to be this. It's going to be x. The x solution is going to be the matrix for D sub x over that general D matrix. Right? And then what was D sub x? That was negative 23 over the general matrix here, negative 28. So I guess we'd call that 23 over 28, right? And then the y matrix, or the y coordinate, is D sub y over D, which in this case would be negative 22 over negative 28. And we would go ahead and simplify that to 11 over 14. And that would be the solution to the system. So it would be 23 over 28 for 23 over 28 for x, and then 11 over 14 for y. And we could do this for a 3 variable matrix. If you can imagine, I'd have 3 by 3 matrices if I had x, y, z, and this would work as well. All right, so that's Cramer's rule, and there's a couple of application.